In this module, we will be talking about few examples of sensitivity and specificity, and we will also discuss various concepts of their measurements of these measures. So assume a population of 1,000 people. Out of these 1,000 people, 100 have the disease, whereas 900 do not have the disease. A screening test is used to identify these 100 people with the disease. The results of the screening test appears in the following table, where you can clearly see that we have 80 respondents who actually have the disease, and a new screening test has tested them positive as having the disease, and vice versa. We use the usual measures to calculate the sensitivity and specificity, which is sensitivity is 80% and specificity is 89%. Apparently, this looks like a good new test where sensitivity and specificity are pretty higher. But there's more to it. Look at the positive predictive value and negative predictive value. We can notice that positive predictive value is 44% and negative predictive value is 98%. Those sensitivity, specificity, and negative predictive value for this new diagnostic tests are pretty high, but positive predictive value for this test is pretty low. Let's take another example for the type 2 diabetes, which is highly prevalent in the older population, especially in the obese population. Diagnosis requires oral glucose tolerance test, where subjects drink a glucose solution and blood is drawn at different intervals to make the measurements out of it. The screening test for diabetes, which is easier, faster, and more convenient, is just to look at the fasting plasma glucose. So, in our experiment, we had 20 diabetics and 20 non-diabetic individuals, where this picture shows their glucose level. Some are low and some are having high, and they are all distributed well within their group. You might notice that the diabetic patients have high as well as low glucose level, and same goes with the non-diabetic patients, that their glucose levels are equally low as well as they are higher as well. So if the subjects are screened using fasting plasma glucose with a low cutoff point, you might notice that this table reflects that it correctly diagnosed 17 individuals having the diabetes, whereas for 6 individuals, it said that it also correctly diagnosed as not having the diabetes, whereas there are few false positives and few false negatives. If we look at the sensitivity and specificity of this test with low cut point, you might notice the sensitivity is 85% and the specificity is 30%. Here's another scenario. If for the screening test, we keep this cut point higher, there will be a new form to it when sensitivity will go down and specificity will go up. It is definitely determining more negative when they are actually negative and less positive when they are more positives out there. But in typical population, there's no line separating the two groups. And the subjects are mixed like this. Whereas in typical population, when these are well mixed, it's hard to determine that who are the diabetics and who are the non-diabetics. Moreover, it's also hard to determine who have the high color. In fact, they are not even labeled with color. So in that situations, a screening test using a high point will treat the bottom box as normal and will identify the 7 subjects above the line as having diabetes, but a low cut point will result in identifying 31 subjects as having the diabetes, where it's very likely that there are a lot of people who are actually not having the diabetes being diagnosed as having the diabetes. So there are a few lessons which we can learn from this example. The different cut points yield different sensitivities and specificities. The cut point determine how many subjects will be considered as having the disease. Moreover, the cut point that identifies more true negatives will also identify more false negatives. And the cut point that identifies more true positive will also identify more false positive. So the question comes that where to draw the cutoff point? We want to know that if a diagnostic test is expensive or invasive, we try to minimize the false positive rate, or we use a cut point with high specificity. If the penalty of missing a case is high, the disease is fatal and treatment exists, or disease especially spreads, then we try to minimize true positives. In that situation, we choose a cut point with high sensitivity. Balance severity of false positives against false negative. This is very crucial when we are determining these tests. Sensitivity and specificity value may be highly misleading in the situations, but it's always recommended that the worst case sensitivity and specificity must be calculated in order to avoid reliance on experiments with few results. Here, I would also like to mention that 1 minus specificity is called false positive rate, and 1 minus specificity is called false negative rate. And the power is also known as the sensitivity. Higher the sensitivity, higher the power of the test will be.